Welcome back to Dead Reckoning, the Human Life Expectancy channel. Today we're going to focus on HLE advancing technologies. Technological advances have helped us to live better, longer lives since the beginning. At first, stone tools, axes, and spears helped us to protect ourselves, hunt, and prepare food. Then fire helped us to remain safe and warm and cooked our food, allowing us to feed our fast-evolving brains. Later, we learned how to plow fields, grow crops, and breed animals to support a new agrarian lifestyle. Since 1900, we've shown that advances such as vaccines, antibiotics, and pasteurization led to the doubling of human life expectancy, HLE. Today, technological advances continue to help us evolve our lifestyles and societies and extend HLE at an ever-accelerating pace. This is the first of our videos which cover the technologies that seem most likely to drive material increases in HLE going forward. There are many types of technologies to consider. First, there's non-medical technologies. You might be surprised to know that traditional technologies such as energy, water, food, and transportation have a big impact on HLE. While these technologies have been around for a long time, recent advances could allow them to have an even larger impact on HLE going forward. Energy technologies are crucial for economic growth, fighting poverty, and increasing HLE. They allow machines to replace manual labor, greatly enhancing productivity and improving standards of living. They're used to help keep us warm, create clean water, produce more food, and to transport ourselves, greatly enhancing the number and quality of human lives our societies can support. They also power information technology, such as smartphones and the internet, resulting in better communication, information, and entertainment, further contributing to health, human culture, and life expectancy. New renewable and nuclear technologies offer the prospect of bringing us more power with less pollution and less risk, enhancing HLE. New water technologies are also increasing HLE. Water is the source of all life on Earth, and access to clean water is essential for human survival. Unfortunately, clean drinking water is becoming increasingly scarce. While 71% of the Earth's surface is covered in water, only 2.5% of global water is fresh, and because most of that is frozen in ice and glaciers, only 1% is available to humans in lakes, rivers, and underground. Since 1900, the human population's dramatic growth has more than quintupled the demand for water, putting a squeeze on this critical resource. In 2019, almost 6% of global yearly deaths were caused by waterborne diseases. These deaths fell disproportionately on the poor. New water technologies, including filtration and desalination, could potentially relieve this squeeze and reduce these deaths. Food technologies, from the discovery of fire to the use of plows and the shift to an agrarian society to the discoveries of synthetic fertilizers and pesticides, have been at the core of driving the increase in human population and HLE. Yet, today humanity's food supply chain is increasingly divorced from our needs. Our historic battle with starvation still exists, but has now been more than matched with deaths due to obesity. And the human food supply chain is the largest contributor to climate change, kills billions of sentient animals each year, and approximately a third of its production goes to waste. New food technologies such as vertical farming, genetically modified organisms, GMOs, and more sustainable sources of protein offer the prospect of addressing these issues, greatly improving human health and life expectancy. New transportation technologies such as autonomous vehicles, medical drones, and flying ambulances could also materially assist human life expectancy going forward. Information technologies are also enhancing HLE. In past videos, we've shown that ignorance is a major driver of deaths. Without key information on prevention, diagnosis, and treatment, people succumb to a whole range of conditions more frequently and die. As such, reliable information on how to avoid, identify, and treat illnesses can materially increase HLE. Mobile access to medical information on the internet is improving health and HLE around the globe. In addition, new personal sensors, bionics, nanotechnology, medical imaging, and machine learning technologies are increasing health and lengthening HLE. Genetic technologies are perhaps the advance with the greatest potential to increase human life expectancy. Genetic technologies offer the potential to identify and predict a range of conditions, to revolutionize human reproduction, to treat many diseases, and to even possibly cure aging itself, resulting in a profound increase in human life expectancy. Since DNA is the code of life, learning to read it and the epigenetic switches that turn it on and off, providing tests to determine what they imply for our health and longevity, and learning to edit and rewrite the genome will profoundly affect us all. Advances in healthcare will also enhance HLE. Past advances in healthcare, including the discovery of the scientific method, the germ theory of disease, epidemiology, and random controlled trials, they've all been instrumental to helping us increase HLE. Two new advances in healthcare are helping us to extend this success. New medical information from electronic health records, EHRs, sensors, medical images, and genetic tests, combined with machine learning, has created the era of precision medicine. Now, pharmacogenetics, non-invasive prenatal testing, and liquid biopsies are allowing us to deliver predictive, personalized, evidence-based medical treatments. In addition, systems biology is making strong advances. Recently, many doctors and scientists have taken a holistic approach to better understand the entire system that leads to diseases. This offers the prospect of altering those systems to minimize or even eliminate their occurrence. Systems biology uses computational and mathematical analysis and modeling of complex biological systems. It transforms medicine by creating models which allow us to predict biological outcomes. Initial research will no longer be conducted in vitro in glass test tubes and petri dishes, nor in vivo in living cells, worms, flies, or mice, but in computers. This will allow us to test biological theories and medical treatments far more quickly and accurately. Then, there's many technologies that offer the prospect for curing aging itself. These include stem cell therapies, metabolic manipulation, genetic engineering, blood augmentation, pharmaceuticals, hyperbaric oxygen therapy, cell repair, organ creation, nanotechnology, and even digital consciousness. We'll show that these technologies are advancing rapidly and with a good chance of success. In future videos, we'll describe all of these technologies and how they might impact future HLE based on our interviews with experts and our own research. However, before we do, we should highlight three astonishing forces that are driving technology's exponential growth and its ability to impact HLE. These are Moore's Law, the ability to collect and share information almost costlessly, and something called network effects. Moore's Law refers to the historical fact that computational ability has doubled and costs have halved every 18 months or so. This relationship has held since at least 1970. This extraordinary progress has allowed us to gather and process information at an exponentially lower cost, making computers smaller and able to do more in less space. Moore's Law enables many advancements in biology and medicine, bringing IT and biology closer together over time. Exponentially greater IT capabilities have allowed us to gather, measure, and analyze the explosion of health data from digital records, sensors, and genetic tests. It also allows us to design and use ever smaller, ever more focused medical and non-medical technologies that impact HLE. While debate continues on whether Moore's Law will continue into the future, the preponderance of evidence suggests that it will. While there's a physical limit to the number of transistors that can fit on a silicon chip, there are multiple possible other materials, including graphene and silicon germanium alloy, and technologies including quantum computing, time crystals, and biological computing that are poised to extend Moore's Law for some time to come. I'll leave a reference article in the notes section below in case you want to research this further. The second force driving new life-extending technologies is the costless sharing of information. IT now enables us to share information almost costlessly and at an exponential rate. Traditionally, this has not been the case. For example, in manufacturing, doubling output commonly requires doubling investment and doubling the number of factories. This makes it slow and difficult to grow and scale such businesses. Digital information is different. Create it once, and you can make endless copies of it, exponentially increasing its value. The cost of sharing is close to zero, whether you're copying a single piece of working code or an entire database of data. As the information component of new medical and non-medical technologies become both greater and better understood, much of it can now be shared almost cost-free by copying the file or sharing the information with other people over the internet, allowing for exponential increases in their application. The third force driving new life-extending technologies is network effects. These occur when increased numbers of participants in a network improve the value of a good or a service. The internet is a prime example of the network effect. Its value has increased exponentially as the number of people using it has grown. The larger datasets from participants in these networks, sometimes referred to as big data, drive the value of Google, Facebook, Amazon, and many other top digital companies. Another network effect results from bringing more people and perspectives together. This means that using crowdsourcing and bringing people from different disciplines together can greatly accelerate learning and development. The revolution in biotech occurred when people with expertise in information technology brought digital technologies, engineering, and tools to biology, which, among other things, resulted in the ability to sequence DNA. Now, instead of digging a deeper hole in their current fields of expertise, many top experts are making great progress by working at the edges of their fields and applying their expertise in other fields using network effects. Together, these three forces have driven an exponential increase in the amount of information that's available. It's been estimated that 90% of all the information man has ever created has been created in just the last 2 years. This staggering tsunami of information gives us truly unprecedented abilities to discover new relationships between data, to advance science, medicine, and technology, and to extend HLE. These advances suggest that increases in HLE arising from many new technologies may be realized faster than in the past. Just as Galileo Galilei's telescope allowed him to see and analyze billions of celestial bodies that couldn't be seen before, today, Moore's law, costless sharing of information, and network effects allow us to see things that we never saw before. For example, the genome and the epigenome. Process the information far more quickly and effectively using artificial intelligence and machine learning. Subject it to rigorous fact-based testing using scientific method and randomized controlled trials. And share information about new technological and medical advances worldwide in an instant over the internet. Imagine how many lives we might have saved if these were available during the decades when vaccines, pasteurization, and antibiotics and public health advances were slowly being adopted globally. The unprecedented speed with which COVID-19 was sequenced and a vaccine was developed proves that similar advances are real and may no longer require decades. It took only days after the virus was discovered to sequence it and to share it with top scientists around the globe, who developed the basic architecture for the vaccine within about 48 hours. Moore's law, the ability to collect and share information almost costlessly, and network effects underlie the exponential advance of the technologies we're going to cover, driving unprecedented increases in HLE. In our next videos, we'll cover these technologies in detail. In the meantime, please hit the like button below, subscribe to the Human Life Expectancy channel to make sure you don't miss our next videos, and post comments for the topics you'd like to have us cover. Thanks for joining us. Till next time, as we say at Human Life Expectancy Inc., hi hua! Please, do what you can to help yourself and help us all to live longer.